Hi and welcome back to Les's Lab. In this episode I have yet another barcode scanner to tear down, so let's stick this on the bench and take a look. So here's an omnidirectional laser barcode scanner, the type that you might find at supermarket checkouts. Picked this up off eBay for just a few bucks. Primary reason for that was the optics in here. All of the mirrors are first surface, which is to say the aluminium coating is on the surface of the glass rather than at the back of the glass, so that avoids like double reflections and stuff. But yeah, pretty cool. Didn't come with a power supply, so it's just going to be a straight tear down and we'll see what's in there and strip out what we need. Interesting case though. I mean, it's quite a hefty case. I thought it'd make an ideal project case when it turned up. Actually, it's pretty reasonable. I suppose, you know, we can stick a Raspberry Pi in there and have an LCD screen. I suppose if we tried hard enough we could make it weatherproof and have it outside, but that's a project for another day. Let's get on with the teardown. Some interesting things about this: if you pull the clip down at the front here, the front glass comes out. So we'll just set that off to one side. The whole purpose for the front glass being removable is so that if it gets scratched or whatever, with, you know, obviously these are designed for, you know, quite hard use, it's very easy just to slip the glass out and replace things, but there's a second piece of glass in it to protect the optics as well. So really sort of well built unit. Looks like there's some interesting components in there as well. We've got a very interesting looking lens assembly. I can see it's got a tiny little mirror mounted on the back of that. That might come in handy for stuff. We've got a laser scanner motor up at the top there. We've got a selection of first surface mirrors, as I've said, and there is a laser diode tucked in right at the back between those two mirrors down at the bottom there. Anyway, let's get this to bits. So I've got some screws that the seller included with this thing. Like I say, no intention of powering this up because I need a power supply. There's a couple of connectors on the back. They're probably odd serial connectors of some description, and then with a power connector. According to the label, it requires 12 volts, minus 12 volts, and plus 5 volts for the logic. But yeah, they're 2003 vintage. So let's get the screwdriver out and open this thing up and see what we've got. We've got a warranty void label. Let's void a warranty. I'm sure it's well out of its warranty now. Oh, bit of plastic gone and flown away. Awesome. So we'll just unplug that ribbon cable. Might as well take a look at this. There's a little PCB at the bottom there, what looks like a buzzer, which would be about right. Oh, interesting. Inside, internally, it's branded Spectrophysics, so maybe it looks like they were responsible for the laser and optics. Little PCB here, presumably for this little button, and LED on top. But yeah, window's nice. It's actually siliconed in, so maybe it would make a decent weatherproof enclosure. Awesome. So now we can see right inside very clearly. We've got all these first surface mirrors that we'll have to be careful not to touch because we'll ruin them. Yeah, pretty cool. So we've got some, can't decide if they're Torex or Allen, but anyway, let's find a thing that'll fit it. I suppose for the price I paid for this, you know, it was like $5. So for the value of the first surface mirrors themselves, I mean, they look like pretty decent mirrors. They'll be certainly decent enough for laser experiments. I mean, it's a bargain already, right? I suppose because we've got a nice case. So there's our mirror assembly. How cool does that look? Absolutely. Oh, there's me, there's the camera. Excellent. So yeah, for parts value alone, these mirrors are great. I suppose they're all stuck on there with sticky labels. I suppose we could get the heat gun on that and extract all of those mirrors. Very nice. And now we can sort of clearly see more clearly see what's in the guts of this unit. Very interesting optical setup down here. We've got our laser diode. And that's directed towards a very tiny mirror that's mounted on the back of a lens. Interesting. So it looks like the laser beam itself bounces off this mirror through the lens onto the rotating mirror assembly, which is here. And then obviously that's reflected off of all of those mirrors that were surrounding the motor. And then when the signal is detected back up, it's reflected back off the scanning mirrors, back through this lens onto a very, very large area of photodiode that's just at the back there, which is another fantastically large photodiode that will come in very, very handy with various experiments for sure. Absolutely fantastic. Right, how can we get this? Oh, we've got screws, more screws. It's quite a well-built unit, really. I was expecting, you know, just plastic junk. Get that screw before it falls out and does damage, I suppose. Awesome. Very, very nice. Let's see what else we've got in here. So this is the board with the photodiode on it. It looks like it's possibly an amplifier of some description. What else have we got? We've got a PCB on the back. We'll take that off and have a look. We've got a motor control PCB at the bottom, which looks suspiciously like it's going to be not a stepping motor, but maybe a multi-phase, you know, sort of precision speed controlled motor. So that could be quite interesting. Let's keep going. So we've got plenty of flat flex, and that just pulls out. So that's the flat flex for the motor. We'll see if we can extract that without damaging anything. I'm being very, very careful not to touch those mirrors as well, because I don't want to mess those up. Incidentally, they do all look like glass. Just tap it with a screwdriver, definitely glass. The optic down here is plastic, which is a little bit disappointing. I was hoping for a glass lens down there. But plastic will do so long as we don't touch it, I guess. So that's the motor assembly pulled out. That feels really, really smooth. I can feel a magnetic field in there, so yeah, awesome. Let's have a look. We've got the PCB on the back. We've got some kind of motor controller IC, but it's covered in a sort of cheap bent metal heatsink. But very, very handily, and this is always nice to see when you're tearing down things, we've got labels on here. So we've got ground, we've got VCC, and we could take a guess it's either going to be 5 or 12 volts. And then we've got two others. One is E and one is FG. E's possibly enable, and the other one, I don't know, maybe we feed it a square wave and it'll spin up. Who knows? But yeah, I suppose we can check that out afterwards and see if we can get the thing to spin up. How hard can it be? You know, we'll try it with 5 volts first, and if we don't get anything out, we'll just jack it up to 12 and see what happens. Fantastic. Let's look at the rest of this thing. We can see plenty of chips down on the bottom. These are old style 2000s chips. Fair bit of surface mount. We've got something socketed down there as well. Let's see, how do we get that off? Looks like just one. They just need a little bit of effort. Some more flat flex to pull out. So there we've got the PCB itself. Pretty interesting. We've got an LDR on there, so that's probably what's responsible for detecting if someone moves in front of the barcode scanner. Yeah, maybe I have to look up some of these things. There's various chips on here by various manufacturers. We've got like Motorola, a couple of Motorola chips, Philips. This is probably firmware of some description, and some other little bits and pieces. Cool. And then we've still got a little bit more to tear down in here as well. We want the laser diode assembly out. So here's our laser diode. We can see the laser diode mounted down there, and it's got its own little, looks like a little driver PCB. That's kind of handy. Cool. Designed 1997. Yeah, and then we've got this very, very interesting lens on the front. So we've got a lens with a mirror mounted on it. If we look down there, let's see if we can get there. It's to line up on the camera angle. You might be able to see the laser diode there, just in the middle. Yeah, so we've got an interesting mirror that reflects the laser diode beam out through the lens, and then the lens, when it gets the incoming light, focuses it back down onto the photocell. Very, very interesting. Like I say, shame it's plastic. Not a real big fan of plastic for lenses, but could be pretty useful. It's interesting, they've flattened off the lens in the middle. It looks like a circle in the middle of the lens there. It's actually flattened off, so the laser diode, it actually doesn't focus through the lens. It just basically passes straight through onto your scanner assembly, and it focuses the incoming light. It's a very, very sort of fascinating design there. It's sort of really well thought out. Pretty cool. So we'll get the photodiode assembly off as well. Might as well have that. So there's our photodiode board. We can see the photodiode there, or is it? Or is that a window? Interesting. We'll maybe have to desolder this metal can and see what's under there. My suspicion is this is going to be a window that's going to exclude everything other than the wavelength that we're expecting through for the from the laser there. It would make sense to exclude daylight. Cool. So I've got one corner up. We'll go and attack the other one. Hopefully we're not jamming the screwdriver too far in there that will cause damage. We're getting there slowly but surely. I see some surface mount components under there. I'm guessing we've probably got a preamp. Right, let's see if we can. Right, we're free on that corner. Free on that corner. Awesome. So it'd be interesting to see what that window is, for sure. nearly there. Oh, that's the board away. So I've got the lid off. I'll just put my hand behind it for autofocus, and it does appear to be a window. We'll just turn it round. There it is. So we're excluding most visible light and just transmitting the red, presumably. So that would be a useful component in and of itself. The circuit board itself, there's our photodiode, and then the rest of it is going to be a preamplifier that we can, I can probably actually put to use for something. Yeah, if we want to detect low-level signals, why design something that's already been designed? Probably be fine. Little Easter egg when I open this up, we've got a little smiley face down at the bottom there. How cool is that? Awesome. Like, nobody would ever see that unless you popped the screening can off like that. That's cool. And again, branded Spectraphysics 1995, so this is obviously quite an old, tried and tested design. Nothing very exciting on the back of the board. There's a bunch of test points though, which maybe, we can maybe solder onto those. Yeah, it'd be interesting to reverse engineer this and trace it all out and actually use it for detecting light. Excellent. So this is the laser diode module out of the barcode scanner. I've taken off the original flat flex connector and traced out the circuit so that I can power it up. It takes 5 volts, and there it is. It's a fairly dim spot. My suspicion is, probably about 670 nanometers or thereabouts. But very, very interestingly, the spot is perfectly circular, even at a large distance. It kind of looks like the spot from a gas laser, to be honest. It's got a really nice Gaussian beam profile. If we measure it with the coherent laser check, we won't find that it's particularly powerful. We get 0.57 milliwatts, which is around about right. But as I've said, a very, very nice clean beam that should come in handy with some optics experiments further along down the line. So I have the motor and mirror assembly stripped out of the barcode scanner here. I've soldered some wires onto the back. It was easy to identify VCC and ground because they're labelled. E I've assumed is enabled, so I've just tied it low, and then I'm feeding a signal in here from a logic analyzer. As far as voltage is concerned, I'm feeding it 12 volts. So we'll just power this thing on. And there it goes, it spins up. Awesome. So now we've got a spinning mirror assembly to play with. Interestingly, the 3 mirrors that are mounted on the motor are at all slightly different angles. So if I put a piece of card behind our mirror there and point a laser pointer at it, we can see there's 3 distinct scan lines coming off the thing. I suppose the purpose of this is to maximize the possibility of capturing a barcode no matter what the orientation is. So if we've got 3 scan lines coming off, that'll reflect off this giant mirror assembly and give us many, many lines that we can possibly capture a barcode with. Pretty cool. I suppose the thing to do with this would be to stick it on the optical bench and fire a green laser at it and have a look at that through the smoke. I'm sure that'll be totally amazing. So we'll give that a go as well. So I thought instead of mounting the mirror on the optical bench, it's kind of predictable what would happen there. We'd get 3 brilliant green lines, right? So instead of doing that, I've actually I've reassembled all of this stuff, removed the original laser diode out of it and replaced it with a green laser diode module. It goes without saying, if you want to attempt to do things like this, do wear eye protection, do take proper precautions, right? Sometimes laser beams can be unpredictable. But anyway, let's fire this thing up. So I've got the mirror on. And then let's power on the green laser diode. Awesome. How fantastic is that? So there's the pattern on the ceiling. If I put my hand in front of it, there's some cool stuff. So I've just turned the lights off in here and closed the blinds till it's mostly closed. I've got to have enough room light so that the camera can autofocus. I've got the scanner set up on the bench there. Let's get some magic smoke. How awesome is that? It's like the Ark of the Covenant. Absolutely fantastic. It's like the barcode scanner from hell. Thanks for watching this episode of Les's Lab. If you want to see more content like this, don't forget to hit like and subscribe down below, and I'll see you guys next time.